Good evening. Good evening, everyone. We just give 1 minute to let attendees to join in. We'll start shortly. Okay. I can see more people joining in. I think we should make a start. The time given 1 hour. It's not. Sometimes it might take longer than that, so we try to keep within 1 hour. And the format today, as usual, is like the typical webinar that we have in IET. So we're gonna. I'll introduce the speaker for the day. We're gonna pass over to our speaker. And then with about 10 minutes Q&A session before we end the session for today. Right. Good morning, good evening, everyone. So the topic for today is managing building energy consumption from head to toe. So before we pass over to our speaker for the night, I would like to introduce quickly our speaker for today, Engineer Tony. Engineer Tony Cheng is a registered professional engineer from BEM and senior member of IEM, more than 20 years hands-on project experience in the design and construction for hotels, healthcare, shopping malls, high-rise commercial office and residential buildings. And he is currently the general manager of UOA Development Berhad. And I can't wait to start the session for today. It's a wealth of experience coming from Engineer Tony today. So without further ado, I'll pass on over to you, Engineer Tony.
All right, thanks very much, Function. Thanks for your short introduction. Okay, I think first of all, I would like to thank the organizer IET and the team by giving me a chance to present for today's webinar. And thank you for those who were able to make it to participate in this presentation. Right, my presentation for this evening will be towards a new building on managing energy consumption, starting from a very conceptual design, install, commissioning of a building. I will also touch a bit on the operations and maintenance of the system by giving some idea regards to the energy conservation practice. Right, let's start. These are the simple outline. The first one, I will talk about the impact of fossil fuel, followed by optimizing full potential at design stage, energy conservation measure, start on the documentation, construction, commissioning, and operation and maintenance, which is a very interesting subject later on. And finally, we have a conclusion on that. Right. So as you can see from this photo, okay, basically this is a coal-fired power plant, and below is actually showing the gas power plant. So what is actually this power plant doing? Okay, this power plant basically, well, for usage. As you can see, what is the impact of fossil fuel in our planet? Obviously, because of they were creating air pollution, acid rain, and smoke, toxic gases, dangerous heavy metal release when coal is burning. And when you're breathing, you will cause asthma, heart disease, cancer, and so on. Okay, and most crucially it's actually affect the environment, okay, and climate change due to the burning greenhouse gases, all sort of things. And again, why are we burning fossil fuel? Okay, what is the reason that we are burning fossil fuel? Obviously, to drive the turbine and create electricity for our usage. Okay, right. So why are we generate so much electricity? As you can see from this per capita electricity consumption, this actually reflects to the Malaysian context. the energy consumed by the per capita people actually increase every now and then. Okay, it's up to 5,000 kilowatt per year per person. Why is it so? Why you are using so much energy? Of course, obviously, is the Malaysian population grow since 1990, as you can see from the top right side, is from 18 million and until to date is 32.7 million. And at the same time, because of urbanization, and people tends to live in urbanized area and city. Okay, so the percentage keep increasing from 2010 until 2020, right? So what is the reason that we are using so much energy? Apart from we are saying that population growth is one of the reasons, because we are living in a hot and humid country, tropical country, whereby we are using electricity to run the air conditioning, using electricity to run the electrical appliances, for example, like TV, microwave, oven at your home. So all this is our usage. That's why it keep going up. But how are we control, or how are we reduce the energy consumption? Okay, in this slide show you the building energy outlook in Malaysia. Okay, so industrial consists of 49.8% as compared to commercial 29% and residential. As you can see from the bar chart, if you add on commercial building and resident building is actually quite similar with the industrial in terms of energy usage. All right. So how are we going to save energy in the buildings? Let me show you energy apportion in the building. Okay. So what are the most highest energy that used in a building? Air conditioning is the highest portion of energy used in a building. It takes up about 55% of the energy, and followed by the office equipment, which is 20%. For example, like your photostat machine, your computer, fax machine, and so on. Okay, and the third one will be the lighting. It takes up about 15%, and followed by your office pantry equipment, like a toaster, fridge, microwave, and so on. So why air conditioning take up so much energy? Obviously, as I mentioned just now, because of a hot and humid weather. Okay, occupants, people like us need comfort. You stay in the air conditioning room, you feel comfort. Right, so what are the factors affecting the energy consumption in a building? Right, so let me show you. Passive cooling technology. Okay, so the most important thing is to prevent heat gain into the building. So what are the things that create solar heat gain? Of course, from the sun. Okay, if more energy coming from the sun to the building, so we need more air conditioning to cool down the building. So we have to look into the building envelope, orientation, and shape of a building, which plays an important role to minimize the direct sunlight exposure and maximizing the natural daylight. For example, try to avoid window facing east-west, because east sunrise and west sunset. Okay, that will help to reduce the cooling load. And solar shading. Okay, solar shading basically can either be horizontal or vertical type, depending on the design. Basically to minimize solar glare and heat radiation to the window. Okay, the less amount of heat radiation going, the less amount energy will consume by the building. And try to reduce window to wall ratio. Okay, generally better to have less window area compared to wall, as wall is always having the best insulation. Okay, however, if you want to have a nice looking building, like the one photo shown on the right hand side, you can go for a double glaze. Okay, double glaze is actually having a very high efficiency and with a good thermal insulation. You can use low E class as well to further reduce the heat gain into the building. Right, point to be taken. By using passive cooling technology, you can reduce the heat gain in the building and reduce energy consumption. So these are the one of the way that you can reduce energy consumed by the building. So the next one, we are looking into how do you maximize energy efficiency? Okay, energy efficiency technology. We are looking into the equipment technology. First is the light zoning. Okay, we provide flexible lighting control to optimize the energy saving. For example, individual rooms to be individually switched, as shown in this picture, with different different colors. Okay, each room have different colors. That means you have individual switch, right? So you can place in a motion sensor as well. So when nobody's in the room electricity, the lighting will turn off by itself, right? So the next one, we have a day lighting. Okay, photocell sensor is normally installed at the perimeter of building. In other words, when the rooms are sufficiently bright, that means more sunlight coming to the perimeter of the building. So the sensor will actually trigger off the artificial lighting. Okay. Next one, we have a LED light fitting. I think this one is very common, and LED lighting is very low in cost and it saves a lot of energy. And we can have a sub-metering. Basically, the purpose of this sub-metering is to let you to do troubleshooting and for energy monitoring purposes. Right, I believe you have seen this logo before with the star rating. The higher the star rating, the more energy you can save. Okay, you can actually see this everywhere in the local shop when they're selling TV, air conditioning system, and even refrigerators. Right, point to be taken, by using energy efficient technology, you can reduce artificial lighting and eventually reduce energy consumption. Right, the next one, energy efficient technology. There are some of the energy saving equipment such as a high efficiency cooling tower, okay, and also high efficiency chiller integrate with VST, and high efficiency pump complete with VST as well. So basically, this VST, we call it variable speed drive, will actually ramp down the pump flow when chiller running in part load. Okay, this will reduce energy and electricity bill as well. You can also have a chiller plant optimization system, which will help you to plan and manage your operations and optimize the system performance. Well, renewable energy, we call it as a photovoltaic system or PV area system, also play an important role as well by reducing the overall building energy consumption. Okay, you can actually get a free energy from the sun, which convert into electricity. It's actually good to have because this is a clean energy. Okay, point to be taken. Okay, again, by using energy efficient technology, we'll reduce power consumption and eventually reduce energy consumption as well. Right. This slide shows you the building energy outlook in Malaysia. Okay, as you can see from the left-hand side, okay, building energy index. So what is this building energy index? So basically, building energy index is actually tools used to measure the energy use per kilowatt per meter squared per year. Okay, this is a tools that we can actually calculate the energy use. All right. So far, take a look at the picture on the top. Okay, this GEO building. GEO stands for Green Energy Office. Okay, this building actually having the lowest energy consumed in terms of meter squared and per year, the whole Malaysia. Okay, this building. And second one is a LEO. LEO stands for Low Energy Office, which consumes about 100 kilowatt per meter squared per year. And EC is the Energy Commission or Suruhanjaya Tenaga, which consumes about 85 kilowatt per meter squared per year. Okay, this B3 building is actually a flagship, a Malaysian flagship building that consume very less energy. Okay, these are the building that Malaysian trying to encourage everyone to go for energy efficiency and renewable energy. Because so far, according to the chart, okay, bar chart on the left-hand side, normal office building, whether it's a government or private, okay, our BI in the range of 200 to 300, which is very, very high as compared to these three buildings, right? So what happened? It is too high. That means more fossil fuel will start to burn and affect the environment. So that's why today's topic, I'm trying to show you how are we going to reduce energy. Apart from the design, as I showed in a few slides just now. So the next one, how are you going to implement in future, right? So this slide will show you the green building certification. Okay, this is just a few examples I show it to you. Besides, there is much more. Okay, we have a green building index, which started in 2009, and MyCrest, and we have BREEAM. BREEAM is actually from UK, and LEEDs from America, US, and we have a BCA Green Mark, which is from Singapore, right? So if you are interested to know more about this building certification, you can actually, I share with you this website. You can actually go to the website and search for it. Right. I also want to share with you the two Malaysian Code of Practice. And this one is a MS 1525, year 2000. It's about the energy efficiency and use of renewable energy for non-residential building. Okay, if you want to design, you have to comply minimum based on this MS 1525 for your buildings. And this is a MS 1837, 2018. It's a installation of grid connected photovoltaic system. Okay, so if you want to install a PV system in a building, these are the code that you have to follow. And you can actually buy this document from CRIM online. And the other one is the ASHRAE standard. Okay, this ASHRAE standard is based on energy standard for building. And you can go for standard ASHRAE 189.1 2020. It's a standard for the design of high performance building as well. Okay, you can actually search on their website. Okay, after I have shown to you what are the equipments and what are the energy initiative during the design, okay? So how are you going to implement it, okay? You can design a very good things, but how are you going to implement it? Right, first of all, we need to have a team involvement, okay? So team involvement is very important. Hold on, let me, something wrong with my slide. Okay, right. Sorry about that. Project owners, okay? Please take a look at the left-hand side, okay? For every successful project, okay, very much depending upon the entire team member, especially starting with the project owners. With the owner's commitment, the design construction and the operating team will definitely receive high motivation and empowerment to create a green design. So remember, always remember owner's project requirement, they call it OPR, okay, including the green design at early stage must be established. The team should work in close coordination, beginning in the early stage. Try to define the owner's objective and criteria based on which the integrated team must work together with a clear directions and focus to deliver the project. Okay, so in other words, you need to have a team, okay, and this integrated team design members, such as architect, structure engineers, M&E engineers. You have the facility manager. It's very important because facility manager are the end user. They know head to toes about the buildings. And you can have a cost consultant and cost estimator, right? So don't forget that the practice work collaboration, okay? Because like conventional design, they only involve consultants and project owners, but they did not tie up with the contractors and subcontractors and also suppliers. But in terms of a green building, okay, you have to practice work collaboration, collaboration with the contractor and supplier, as their input at the early stage are important. For example, contractor are well versed in their many installation works, setting up of equipment, and supplier will advise you on the equipment size. Okay, so you don't worry about the headrooms, your equipment cannot fit into your plant room. Right, so the next slide, the next important thing is the drawings and documents. Okay, you have your design, you must have your proper document. So what is the purpose of this document? Okay, normally at this stage, consulting engineer or consultant, okay, will actually prepare detailed drawings and specification according to the approved OPR, honest project requirement. Okay, previously we discussed, and that has been confirmed during the design stage and development stage. Okay, we call this a tender process. Basically, this tender process for getting a contractor and agreeing on the price. Okay, so bear in mind that to ensure the drawing and document is accurately written, so that to avoid dispute once the job has been awarded. Any dispute may affect the cost, time, and the design intent. Okay, so it's very crucial. We don't just talk about design, but it's not proper documented, we have problem in future. Right. So in this stage, okay, I call it a construction stage. I will show you in terms of to have and manage building services. Okay, if you want to manage building services, a proper managing of building services, you have to look into stage by stage, especially when you're concerning about the building energy. Okay, you can have a very nice design, you can have a very good system in terms of efficiency, but during the installation, if it's not proper installed, you will not meet your design intent. In other words, you're wasting your money. Right, let's look into that. I call this a poor installation. As you can see, the air conditioning ducting, the flexible ducting is too lengthy. Okay, and the middle picture, you can see the square box, a plenum. Okay, this actually create an air turbulation. When air turbulation occurs, the performance will lost. And this second slide will show you the picture. Obviously, there is a 90-degree bend. What will happen to this bend? Of course, you create an air turbulation flow, correct or not? So all this will actually have a very high friction loss. And what will happen is you have less air. So when you encounter you have less air, then you turn the air faster, correct or not? You increase the air speed, you increase the speed of the fan. So all this will create more energy. Okay, so try to not to have all this. This is obviously from the coordination purpose. You can see the ducting is actually try to avoid the beam, and divert to the opening as shown in the drawing. And the bottom picture showing the FCU. I call this a bottleneck duct because the way they install, they squeeze the neck of the FCU, end up there will be a high velocity losses. So when high velocity losses, that means the FCU have to work harder, correct or not? So they will use more energy, right? So the next one, this is, look at it, you will feel a bit funny, but when you think about it, you feel very sad. You have a very efficient FCU, high efficiency system, but the installation are facing to each other. What will happen if facing to each other? There will be a backflow, the system doesn't work well. So all these are performance losses, okay? And this picture show an FCU, okay? It's actually located very close to the structural beam. And what will happen is you have a return air problem. This is the first one. Second is you have a maintenance issue. Okay, how are you going to remove the filter from the FCU? If for those unsure, because normally the FCU, the filter actually placing at the back of the FCU. These are the return A as shown in my cursor. Okay, so all these are performance losses, right? So the other one is very common. Okay, you cannot actually visual by using your eyes to see. Okay, this is actually a misalignment, a pump and a motor. Okay, you have a chill water pump when you install condenser water pump. If the pump and motor alignment is not in line, you will have problems. What are the problems? Of course, you will increase the friction loss, excessive wear and tear, vibration and noise issue. So the pump have to, the motor have to drive harder. So that means you increase energy consumption as well. So what for you have a high efficiency motor if the pump is not being installed properly? Correct. So after showing this all the photo, try to inspect the site whenever your equipment has been installed. So again, for contractors or consultant, resident engineer, they should look into this very tediously. Right, the next one is how to minimize the gap between the design and what is being built. Okay, so ongoing construction stage. During this construction stage, okay, review product submittal to look for potential problem. Okay, from the shop drawings, material sample or method statement actually are part of the procedure and process to make sure the contractor is correctly interpreting the specification and drawing and is not missing any important details. So I encounter many contractors when they submit drawing, they thought we are catching them to for cheating or what. So it's not that the reason, but sometimes because they're too much job, they misinterpret the design. So most importantly, that's why we have to check and let them know. Okay. So of course, review method statement is very important because the purpose to review method statement to ensure step-by-step implementation, correct practice for installation, testing, and safety measure. Okay. So the method statement for each equipment must include the scope, responsibility, tools and equipment, material, installation procedure, and also inspection risk assessment, the test plan and quality control as well. Right. So commissioning specialist, okay. So during the construction, the commissioning specialist in Malaysia, green building, we call them as a commissioning specialist, okay. In short, is a CSX. In US, they call them as a commissioning agent or commission authority. But just a different name, but their scope, their purposes are the same. Okay, so during this construction stage, they have to frequently visit the site to check on the system, okay, and to test portion by portion and zoning by zoning of the system. Most important thing is they have to witness on every test, okay. So normally the commission specialists, they visit the site, ensure proper site installation, and they're checking, for example, like electrical connection, whether it's correctly installed, mounting, fastener, pipe secure, ductwork connection, and so on, right? So construction best practice method. Okay, imagine, I always saw this happen in the construction site. You have a issue, you have an aircon, and just leave the site like that. As you know, the site, a lot of dust, a lot of water going around. So all this will stick to your equipment. What happens if you just start and operate the equipment? So all the dust, all the chemical things went inside the building, right? So protections are one of the most important things. You have to protect the equipment, wrap them up as shown in the photo, okay? So to avoid having those indoor air quality problem in future. right? Next, we come into this stage, which is the testing and commissioning, right? So basically at this stage, I would say this is the final stage of testing. This stage is actually testing of the overall system. Of course, it's not testing the pipe leakage or the pressure test for piping, okay? Pipe leakage testing, pressure test piping, that one should have been done during the construction stage. Okay, now this is the overall testing and commissioning. We involve testing of the system to make sure the system meet the design intent. Okay, so normally at this stage, the commissioning specialist will conduct a performance test on the overall system, of course with the help from the relevant specialist trades to perform the test as previously accepted in the design review. Okay, so basically the commission specialist will witness the test procedure and the result ensure the system is functional as according to the design intent, right? So at this point in time, many systems still cannot be fully tested until the building is occupied. So there will be ongoing tests at the later stage by commissioning specialists, or they call it ongoing commissioning phase, right? So there's a point to remember.
Hello?
I mentioned that control system is very important. Okay, if improper test with actually you have a losses up to 30% energy consumption, right? So for those who are interested in this article, you can actually search both author in the website. All right, you can Google, you can find them. Right, I just want to share with you, these are the ASHRAE standard for testing and commissioning process for the building and system, right? Again, you can actually buy, if you're interested, you can actually buy from the ASHRAE website. Now we come to the operation and maintenance stage. So as I have go through previously, I explained on the design, the energy initiative that you have to provide, and then I go to the process of tender documentation stage and construction stage on the installations, and finally reach to the testing and commissioning. Okay, so these are the progress that you need to look into if you want to have a high performance building. Okay, so all this must be in line, so end of the day your building can meet your design intent. Okay, so assuming everything is okay, fine, okay, the building start operating. So what you need to do during this stage, operation and maintenance stage. Okay, let's go into that. The function of O&M. Okay, so operation and maintenance management. Okay, keep in mind that a building performance is also very important. It depends upon how the building is operated and maintained. Okay, the key ingredients of making such a program work, as shown in this slide, hire a quality personnel. Okay, train them well, provide quality tools, and okay, wait, let me go back. This energy conservation practice, a lot of people doesn't know what is meaning of energy conservation practice. Okay, but don't worry, I will show you after this slide. All right. So as I said, okay, you must have a quality tool. Okay, the tool, when I mean quality tool, means a proper tool. Okay, and you always need to keep your spare parts. Reason being is if anything down or break down, you can change it. Otherwise, you have to wait for a few weeks to get the order of the equipment, right? And ensure device in good condition. Good condition means a good working order, including yearly calibrations. And you can also embark to energy management ISO 50001. Okay, this is actually more towards ISO for an organization. It's actually a framework. Okay, by having this, it can actually help you to save energy in the building, right? And of course, you can have a preventive, corrective, and predictive maintenance program. All right. So preventive and corrective is actually a conventional maintenance. Nowadays, many organizations are going for the predictive maintenance. This one involves AI and artificial intelligence, whereby the digital tools, the system, the software actually can help you to predict when it's the right time for you to service the equipment and when it's the right time to replace the equipment. Right. So you can have an energy audit. Okay. So if your building has been operated more than 4 to 5 years, it's good to audit your building. Okay. I think next few slides, I will show you a simple what is meaning of energy audit. Okay. So of course, when you audit, you need to do measurements and verification, right? Okay. So take a look at this one, maintenance. Okay. What happened if a clogging filter? Okay, for those who didn't know what is this, I can actually brief you. This is actually an ASU, air handling unit. This showing the back of the ASU. This is the air suck in. Okay, this is an air conditioning system. The air will suck in and discharge the cold air in front. Okay, so look into detail. A clean filter. This is a filter. Okay, a clean filter is supposed to be in a white or brownish color, but it's not a dark color. Okay, this obviously the filter is not being washed at all. So you can see the accumulate dust to the system. Okay, so what will happen to the system? Of course, the ASU will operate at a lower efficiency. Okay, the system will have to work harder. Okay, meaning the system will consume more energy, right? Okay, so when the force air into the system, what will happen? Those allergens will be released into the air that you breathe. So washing, cleaning, maintenance is very important in building services. Please take note. Right. Okay, just like I mentioned about the energy conservation. Okay, what is energy conservation pyramid? Okay, for building management, this is very important and crucial for them to know. Okay, so basically this pyramid of conservation is actually helps building owner prioritize which of the many energy saving steps to taken. Okay, each of the pyramids level represent different energy saving measure for the building. For the best result, the pyramid should be read from the bottom to top. Okay, from the bottom to top, not from the top to the bottom. Okay, why? I show you. Okay, first we call it tier 1 energy conservation. It's the decision where based on behavior and operational practice by using less energy. For example, by turning off the light when you leave the room, unplugging appliances when they are not in use. Okay, so walking instead of driving are also examples of energy conservation. In other words, you try to conserve, try to save energy. All right, this is the meaning of energy conservation. So the next one will be tier 2, energy efficiency. So energy efficiency meaning using less energy to get the same job. Okay, using less energy to get the same job done. So how? For example, an LED light bulb that has earned an Energy Star label, okay, normally uses 70 to 90% less energy as compared to the incandescent light bulb. Okay, these LED bulbs use less energy while providing the same illumination, right? I can use less energy, but I can still get the same brightness. So this is called energy efficiency. Right, next one. If tier 1 and tier 2 okay, meaning the energy conservation and energy efficiency are well utilized, okay?
There's some glitch there. Engineer Tony, you're muted. Sorry.
Oh, sorry. Just now the line cut off, is it?
Yeah. It's okay. You can reshare your screen.
Oh, for how long? I have no idea. Maybe I can
Just
go back.
a few seconds. Yeah.
Oh, a few seconds. All right. So can you see the slide now?
Not yet.
Not yet. Can you see now?
Nope, not for me. Can others see?
Let me see the screen. Let me share the screen again.
Yeah.
Because it's a line cut off.
There you go. Yeah. Okay, got it.
Right. Let me enlarge. Okay, so where were we just now? I talk about tier 1.
Yep,
okay,
got it.
Tier 2. Okay, and tier 3. So I mentioned if tier 1 and tier 2, if you are well utilized, okay, we can use less renewable energy. Okay. Right. Energy audit. Okay. In this topics, I just give you some simple summary about what is actually energy audit. Okay. If you really want to go into detail, so this topic may actually take 3 to 4 days. Okay. They actually have a cost, a certified energy auditor. They actually have a cost for this one. Okay. So, but however, in this one, I just give you a brief summary what is actually about energy audit. Right. So what is energy audit? Okay, it's actually a tool for identifying energy efficiency potential measure, and it comprises a detailed analysis of energy performance of an organization, equipment, and a process. So in other words, what does it mean? Okay, why the need to perform energy audits? Okay, for example, like if you perform energy audit, okay, you get to know their database. Okay, for let's say for building services, we have a building control system. Okay, we always keep the database in the system. Okay, so the database is very useful for your future for troubleshooting. Okay, for example, like evaluating the existing energy management practice. So after 4 years that you are operating a building, you do your maintenance, but how sure that you are doing the right maintenance, whether whether the practice that you have done, is it the right way to save energy? So you don't know. So that's why this energy audit come in. Okay, they have a keep record, they can show you, and you can actually observe what is the level of energy management practice that you have done. Okay, and they also energy audit also allow you to identify opportunity of energy saving. What does it mean, opportunity of energy saving? So for example, like after you're running the system for a few years, you're not sure the efficiency of the system. Okay, the efficiency of system equipment, as you know, it will drop, right? So from the energy audit, you will know the system is not efficient. Then you will start to replace a more efficient system. During that time, we call it retrofitting. Okay, for example, you can actually replace a chiller. Okay, you can actually replace a pump, right? So, oops, I think it's something wrong with my screen again. All right. What are the benefits of energy audit? As I mentioned, energy saving, reduce maintenance costs, fewer breakdown, and quality improvement, right? So these are some of the resources needed for an energy audit. I just show you these are the equipment that we needed. For example, like ultrasonic flow meter, cooling load. We have a power data logger, actually to measure the overall electrical load, right? And also we have airflow balancing system. Okay, this to balancing the airflow in the office building. And we have the air extraction flow meter on the return air side. And also we have airflow measurement in the ductwork. Okay, these are just a few simple example I'm showing to you. And I also share with you the reference guide for conducting energy audit. This is one of the guide from Energy Commission of Malaysia. Okay, they call it Suruhanjaya Tenaga. And also you can get from the ASHRAE. Actually, ASHRAE have a lot of standard. Okay, every single part of the system, design, maintenance, they have all the standards. Okay, if you browse to their website, you can get all these things. Right. So that's all from my slide. These are the key takes away. In overall, I have actually show you the understanding of energy conservation, method to prevent heat gain into the building using the passive cooling technology, integrated energy efficient technology to improve the building energy consumption, and also integration design team that you have to work together and conduct detailed review on your technical submission, which is very important to ensure everyone interpret properly. Okay, and commissioning of the system when you hand over the building, and last but not least, operation and maintenance management together with the basic energy audit. Okay, before I finish my slide, this is a simple way. I just want to show the simple way to save energy in a very inexpensive solution. Everyone can do this, okay, by setting the air conditioning at home, even though at home, not just in office. You always set 24 to 26, okay, but some people, they like 18, I don't know why, okay. Switching to sleep mode on desktop when you're not using it, okay, and use energy efficient appliances, the one with the stars. The more stars, the better it saves energy. And last but not least, unplug all your appliances when you are not in use, okay. Well, thank you so much for your kind attention. And I hope today my sharing can actually benefit you all. And thank you very much to all participants that are able to wait until I finish my slide. Thank you very much. And I pass back the floor to you, Encik Fauzian. Thank you.
All right. Thank you, Engineer Tony. I would like to invite the audience today. Feel free to ask your questions in the chat. If you've got any questions, take the opportunity that we have Engineer Tony here. But while waiting, I have a few questions on my mind. This requirement, right, to have like green building, for example, is there a minimum requirement set by our legislation, local legislation, or is it more of a choice for the building owner or developer to go for green building?
Okay, well, unlike in Singapore, okay, in Singapore, the government already said every new building must have a certified level of green building. Okay, but so far in Malaysia, more towards on private. Okay, whether you want to go for green building or you not go for green building. But so far as I know, based on the authority submission, especially on DBKL, okay, so they start to implement, okay, by having a 30% of renewable energy. Okay, so of course this is not a fully green building sort of green building, but they emphasize on renewable energy. Okay, but I believe at the moment many private developers or government, even though in Putrajaya, okay, most of them, they go for energy efficiency system. They try to go up for green buildings. Because I would say if a new commercial building, even though they are not go for green building, but the design they have already, I mean the baseline they have set for green building, at least a certified level. For example, like if you buy a chiller, everyone going to buy an efficient chiller. Nobody going to buy an inefficient chiller. So that one is already part of a green building. And also the glass panel, as you know, the sunlight, all those things, they always have a double glaze. So there's also a part of the green building as well. It's a baseline.
Okay, all right, thanks. And another thing on my mind is you mentioned about this under the auditing and servicing and maintenance, right? Using the ultrasonic flow and things like that. Have the buildings these days start adopting IoT technologies, for example, and start using these sensors throughout the building to monitor in real time those kind of information? Is that in practice currently?
Yes. IoT, yes. I think in the building industry now, they started to have, because IoT monitoring, they're using artificial intelligence, machine learning to run the system, to predict system. So all this is not something new. Actually has been practiced in, especially industrial manufacturing for the machine. A long time ago, they already practiced using this IoT and machine learning to predict the failure of the system. But in the building wise, because the system is very less compared to the industrial. So I believe they are just started. So even though in my own building, we actually started look into this for our next new coming building. So we are looking into this IoT and sensors and machine learning, as I mentioned. Especially I will prefer to predict the maintenance when we're supposed to service, because you never know when the equipment going to break down. As you know, during the facility management side, people tends to go in and out. Just like a doctor. If a patient always come and see you, you know the doctor know you very well, right? If the maintenance guy keep changing their work, a new guy come in, they don't know when's the chiller or pump going to break down. He has to start all over again. So now we are very depend on this so-called digital tool. Yeah, you are right. We are start to have all these things now.
Yeah, I think also these days you can hear people talk about digital twin, for example, right? So all this data and sensors going to one central location. I wonder whether that's already in practice in building management now, to have a centralized dashboard kind of thing to monitor the health conditions of all your key equipments in the building and to monitor in real time. Is that already in practice or coming up?
Is some of the building already in practice?
Right.
Besides, this system is actually linked to the building control system. The building control system, they call it BCS or EMS, already long time have. Okay, so now they start to incorporate this, and people start to using a mobile phone to actually read from the system. Actually, it's very friendly user. It's very friendly user. I myself always recommend to have this nowadays, because without IoT, it's actually very difficult to know all, because we are maintaining many buildings. So we maintain many buildings. For those organizations who maintain buildings, it's good to have a centralized system. It's always recommended. Yeah, it's correct.
And I think it's always a trade-off, I imagine, to go with green. Am I right to say, if you decide to go on a green building, the cost is normally higher, but in the long run is cheaper because the maintenance cost is lower? Is that a right effect?
Okay, I would say, you see, green building GBI started 2009. There's a first Malaysian green building certification body. Okay, started 2009. That time, our first building, we are struggling to get a certification, and we observed that the cost that time is about 8 to 9% of the overall construction cost. Because that time nobody talk about green building, and it's quite expensive. But 10 years, I think about now it's 2021, it's about 11 years to be exact. So as I mentioned just now, many new buildings, when they're coming up, their base design already the green building. So in terms of percentage, it will be less than 3% if you talk about green building initiative. Like for example, I mentioned the chiller, your base building, you already expect to spend your chiller, and then you expect to spend your double glazed glass, everything. So additional 3% probably are those new technology that you incorporate in to further enhance the building efficiency. So I would say nowadays is green building is not expensive. It's not expensive.
I think it's a no with the green building, you know, for future proofing, right?
Yeah.
Okay.
Correct.
I've yet to get any questions from the audience. I think the audience are quite shy today, which is fine. Feel free if there's any. Otherwise, I think if no further questions, I think we can adjourn the session. But before we adjourn the technical talk today and sharing from Engineer Tony, I would like to promote our next topic on the IET webinar session. The next one coming up is on Saturday, 25th September. You can have a look on IET website under the topic of Route to Chartered Engineer, Route to CEng. Speaker from Assistant Professor Yuring IR Victor and also Professor Dr. Zuhaina Zakaria. So I think it'll be an interesting topic for those aspiring to attain CEng status, professional registration status. It will be a good session to attend to. And you can have a look on our IET events website to register and book your time and interest. Other than that, without further ado, I would like to adjourn the session until we meet again. Thank you again, Engineer Tony, for your time and sharing to the audience today to continue to promote to the engineering community. And hopefully we'll see more of you again in the future technical webinar session from IET. Thanks again, everyone.
Thank you very much.
Thank you.
Thank you. Bye-bye.